Let's have a look now at another interesting factorization. We're going to factorize x to the power of 4 plus x squared plus 1 by adding and subtracting x squared. So let's see how this works. Okay, so what I'm going to do is let's just write down x to the 4 plus x squared plus 1. So that's the original expression. And it says here to sort of add and then subtract x squared. So we're not really sort of doing anything. I mean, you're sort of adding something and then taking it away somewhere else. Okay, so we have x to the 4 plus x squared plus 1. Then we're going to add x squared, but then we're going to sort of subtract it again. So we haven't changed the value of the expression at all. Okay. However, when it comes to factorizing though, it can have some desirable effects. And hopefully we can then factorize this expression. All right. Now what we can see here is we've got the first two terms. So again, just by inspection, if we factorize the first two terms, the first pair, we can take out x squared. There seems to be a lot of x squareds everywhere. That's kind of a bit of a clue as well, isn't it? Okay, so first two terms. Okay, take out x squared, we have x squared plus 1, which is great. Then you have sort of the last three terms there, 1 plus x squared minus x squared. But I'm going to switch these two around, and the reason why I'm going to do that is because I want it to look like this. It's addition, so I can sort of swap terms around. They're commutative. Okay, so that's going to be x squared plus 1 minus x squared. Okay. Now, you notice that you have an x squared plus 1 here in brackets, and then you have another x squared plus 1, which we can put in brackets. That doesn't change anything. I mean, it's all added together. So adding brackets doesn't change the value either. It's not like it's sort of changing the order of operations in any way, in such a way that it changes the value. However, ignoring the x squared here, so taking that away, you can see here that we have a common factor, at least with the first part of this expression. Okay, so I guess what I'm saying is gaze your attention here. Don't worry about the minus x squared. Okay, we have one lot of x squared plus 1, so why don't we put a 1 there just to make it clearer what we're doing. And now let's factorize by grouping in, basically effectively grouping in pairs, isn't it? Okay, so we've sort of kind of done that. Take out the common factor, which is x squared plus 1. So that's the common bracket there. But then we're left with x squared plus 1 again. Then we're going to add on this last term here, minus x squared. Now you might think at this point, okay, well, have I hit a dead end? Well, no. Let's have a look at the brackets that we have there. Aren't they the same? That's a perfect square, isn't it? So moving on, so next line. Okay, this is x squared plus 1 all squared minus x squared. Okay, so this is just expressing the perfect square in index form, so using the power of 2 there. And we can see here that we have a difference of 2 squares, and that can be factorized, of course. So that's, if you recall, a difference of 2 squares. Okay, so if you have a squared minus b squared, okay, that's the same as a minus b, a plus b. All right, let's keep going. So that's going to be sort of a minus b. That's our a. Okay, so that'll be, okay, so I'm just going to write a there. Okay, so that's going to be x squared plus 1. So that's our a. In fact, I'll write it here just to make it a bit clearer. That's our a, and that's our b. Okay. So a minus b, okay, we'll take the square root of the x squared, which is x, and then a plus b. Okay, so it's going to be x squared plus 1 plus x. Okay. If you wanted to write it sort of so it looks a little bit neater, you could maybe write it like this and just write it in the order of the indices. So the highest power first, x squared minus x plus 1 outside of x squared plus x plus 1. And that's it. Thanks for watching.